Good afternoon, everyone. Good day, good morning, wherever you are. Welcome to the third session of this series where we'll discuss Siemens PLC hardware configuration. We already had two videos concerning this. You can watch that on this YouTube channel. Today we'll be doing some configuration of some hardware. I'll also be discussing some things generally which are feedback from your last submission as well. So before we go right into that, on our GitHub page, if you go to the PLC training on the hardware configuration, which is number 4, you will find that I've just uploaded a video, not a video, a file, first hardware class.zip. That's a project which I compiled and uploaded for you, so you can check that. I also have some information to share with you based on the last class. So for us to go right into today's class, I have an architecture here which I just basically designed, which is what we'll use for today's training. Right here we have an S7 1200 CPU. It has an integrated digital input, digital output as well, digital input, digital output. It's a 1PN PLC, so it has just one port and just one networking line for you to connect your Ethernet cable, Profinet cable. In between it, I have the Scalance switch. Here I'm using a switch just because we only have one port to connect and I want to connect a remote I/O device. So I need something to help me split the connection. So right here we have a switch. This is also from Siemens. It's called a Scalance switch. In the industry, you'll find this quite a lot. Here we have what we call a remote I/O. This CPU has input and output ports, so you can directly connect input and output. It also has, this one does not have analog input and output, does just digital. In some cases, okay, yeah, I have one analog input on this one actually. So in some cases you have input and output, analog, digital, and these are integrated. In the last class, we talked about S71500, where you have the input and output connected beside it using the back pane. Here, we're using a remote I/O device, which means the input and output are remote. They are not located where the CPU is located, which is usually sometimes the case on the field. So you have some sensors or some devices located some meters away from the PLC, maybe from the PLC cabinet, and instead of you running all the device cables to the PLC, you just put a remote I/O on the field, you run all your devices into the remote I/O, and then you connect your remote I/O using an Ethernet cable. So the lines that you see here in green are Ethernet cables. So from the PN, we will have an Ethernet cable connect to the switch. We will have an Ethernet cable connect from the remote I/O station to the switch. And here I have my PC. We will also have an Ethernet cable connected from the switch to the PC. We have a 24-volt source, which is external to the system. So right there, I'm connecting 24-volt power supply to the PLC, 24-volt power supply to the switch as well. I didn't show that here. So there's a 24-volt power supply to the switch. There are 24-volt power supplies to the ET module. So to quickly explain what you see on the ET module, there is a 24-volt external power supply coming to the main module, this guy, and I'm able to loop power supply from this to this white base station. This white base station then supplies the dark base station, so I don't need to connect power supply to this. I also have another 24-volt power supply connecting to this white base station, and then this white base station connects to this guy. These remote I/O stations are connected on the side, so they share there is this device which terminates the bus line. This is a service module. It terminates the system. It lets the device know that this line is complete. We're no longer connecting any other thing. You see, when I remove the device, now we have red, the red light blinking on this module, which is saying something has been removed on the line. So these devices are connected on the side. I'm not supposed to remove this while it's powered on, but because I wanted to show you, so I'll just do that. So this guy connects to this guy, and that's how the power is from this. You see these three lines? The power is connected from here, and data information is connected from this top part of the module. Because we have power supply connected to these guys, you can see that there is a power light on here. There's power on, and because this guy shares powers with this, there's power on here. If I take out the power supply from this guy, see, the power light goes off, which means this line, this two bases do not have power supply. You can already see it here. There's power here, there's power, but there are no power here. But these lights are blinking because this guy is still able to send some communication on the line. Although nothing will happen to this because we don't have power supply on it. So if I connect the power supply back, now it shows that power is on it directly. So what we will do now is to do the configuration of this device on TIA portal. So I open my TIA version 20, and the first thing we want to do is, of course, we want to configure our CPU. I'll create a new project. I'll just call it training S7 1200 hardware config training S7 1200. Yeah, I'll put this in my folder desktop training. So I say create. So it creates the environment for us to create our project. Okay, so we have our system right there. I want to open this file where I've already tried to copy. I've already tried to copy the other codes which we would use. So I'll just quickly show you that here. Yes. So we have our CPU, the remote I/O, and interface modules, and all of the devices are here. So I'll remove this. Our CPU order number, I'll just quickly type this in here, 6E1211-1A-E40-0X-B0. Yes, and then I'll switch sys GK528-0B-A-2A-B2. So In some cases, you could have the devices in front of you like this. You have to do the hardware configuration. For example, if you're sitting or standing in front of a control panel, you have the devices in front of you and you have to read out the order number on each of the devices. In some other cases, you have a wiring diagram. And in the wiring diagram, you have all of these numbers. And then you have to figure it out. Just like I've drawn it like this, you can have a wiring diagram to show all of this with the order numbers, and then you have to program that. I've also included some IP addresses here. We'll get into that soon. So let's go into our software to program. One of the first things we need to do is add new device. So we want to add, we know it's an S7-1200. We can directly search for it because we have the order number, right? So what we have here is DC, DC, DC. So it should be somewhere on this line. Then I'll confirm with the other number we have. So the other number we have is 2111AE40. This is it. So this is the other number we have. We need to be sure this is 211, right? So we need to go here because here is 212. So we should be somewhere here. Yes, should be this. So if I click back on this 2111AE40XB, yes. So on the description, it tells you basically everything this guy can do. You can also check the version which you want to install. I'll just go ahead with the latest version 4.7, which the software is given to me. So I'll click on OK. And then it would add the device to the system. It will create all the properties of physical devices that the PLC can connect to. It will create the hardware catalog of the devices that can connect or work with this PLC. Basically, the software will prepare the environment for me, which we can use to program this PLC itself and every other thing that can connect with it as well. Okay, good. So we have our PLC, and then once again it comes up with this protects PLC configuration. So if I basically click no, I don't want to protect PLC, right? So I don't want to protect the PLC configuration. We had this in one of the classes earlier, and there we needed to protect PLC. There we showed how to protect the PLC. In this case, I don't want to, which was one of the issues some of you had. Mode for communication, only allow secure communication, fine. Enable access control. No, so just disable access control. We'll delete all online user management data on the PLC. Yeah, I don't want access control. Just allow people to be able to access this PLC. For training purposes, right? Yeah, I don't want any administrator setup. Access level, no access, complete protection. TI portal users and HMI applications will not have access to any function. Password for full access, password for real access. Let's continue. I don't want any. Finish. So we have our PLC. It goes back to this protection. I don't want any protection. So let's see what that gives us. Like I mentioned when we started this series, this is my first time of using version 20, so we will be learning some things together. Yeah, usually, like I usually say, it's usually best that you name things because once you start programming, those names would help you. There are some higher level programmings that you would do that you need all of these names. You need port names, different naming. So tags, writing, putting names on devices really help. So I'll just quickly name this as our S7-1200 training PLC. Yeah, so that's named. We have a PRONETA interface, just 1x1, right? I'll name this interface as well. Usually I like to do that. So we can say PN, or we can say CPU PN X1. Now, new subnet. So let's say, yeah, we want to add a new subnet. I'll show you what this is later. Um, IP address. Let's check in our documentation. What IP address did we decide to use? 168.1.1. 192.168.1.1. 1.1, 255, 245, 245. Yes. Generate Profinet device name. Every other thing looks good for now. So we have digital and digital output, which are directly on the devices, right? So I just leave everything like this. We have analog input. I'll leave it basically like this, right? High speed counters as well. Pulse generators. Yes. Yes. Startup, leave it as it is. Cycle, communication, load system, and clock memory. Please enable this. We will discuss this in further trainings, but just enable it. Even if you don't use it, just enable it. It's something that is quite useful later. Multilingual support and then time of the day. Yes, I always advise you use the time of the day for wherever you are, wherever you'll be using the PLC because it helps. Protection and security. So again, it's saying confidential PLC should be encrypted using a password. Because the project is not protected, the password is not saved in the project and must be entered during download. Okay. So protect confidential PLC configuration. So let me just do this setup. I'll just I'll just enter something, at least 10 characters. Whew. Again, I don't want to do this. So let's see what happens. I don't want to do that. OPC UA, yes, let's activate OPC UA server. Probably we might come to this in future trainings. So I'll say yes, activate. Advanced configuration for now, just leave it connection resources, overview, and then runtime licenses, of course, because we've enabled OPC UA, we need to mention the type of license. Here it says basic, so just give it basic. It's usually available over there. I think for now we have majority of what we need to configure. If you look at the IO tags, it shows you this is the clock that we enabled. This is the address that it's generated automatically for our analog input addresses, which is on the PLC. The analog input that comes with this PLC itself. Also, it's generated some addresses for our Boolean, our input, sorry, input addresses, which is 1, 2, 3, 4, 5, 6, 6. This is output 4. So we have 6 inputs and 4 outputs, basically. We will come to tag tables, we'll come to all of this later. I think for our PLC we're fine. So one of the first things we'll do is click on this. Let me expand this a little. Click on this, compile to see if everything we've done works. And then we'll keep an eye on the info table to see if everything looks good. Like I usually mention, these 3 icons are enabled so I can see errors, I can see warnings, I can see just information. If there are any alarms, I expect to see it. Currently, just 0 errors, 1 warning. And one of the warnings is that unsecured communication is permitted. Fine, no security is, yeah, no security is activated. PLC communication was renewed due to changes to the hardware. Fine. So everything looks good for now. Now we have to add these other guys, and because we will be connecting to these other guys using network connection like we've shown here. Usually I'll just go to the network view. In the network view, you see a different view to the PLC. Again, let me go to the device view. On the device view, you see what we can see here on the catalog. It's showing us the CPU, communication boards, digital input, digital output, different devices that you can add on this rack. However, when you go on to the network view, it shows you what can be on the network with this guy, not on its rack. So for example, when I go to the network view, it shows me the PLC, which is currently sitting alone. And here you can see all other catalogs. Let me close this. You can see that what you see here is different. Let me switch so you can see it properly. This is what we see when we are on the device view. When we're on the network view, this is what we see. Things that we can connect to this guy using network. So first, I mentioned when we created subnets that I will come to this. So the subnet really shows up when you get into the networking process where you want to network the PLC. Like I mentioned, I usually like to name things. So I'll go ahead and name this subnet which I've created. So I can say CPU subnet. Just name it directly like that. Basically, that's all I just want to do here. Every other thing for now remains the same, right? So here you see the CPU subnet. Now I want to add the switch first, right? So if I want to add the switch, I can directly just type it here, or I can also go into each of the folders to look for it. Here in front of me, I have a Scalance V20 switch, so I can look for something like this, which looks like this. But instead of searching, if you already know the order number, just type it in. I know the order number for this, so I don't want to take a lot of time. I'll copy, paste, and then I'll click enter. And then it will search, it will look for it for me on this hardware catalog. Yes, so we find it. So I'll add it. I'll just put it on the network there. Okay, so it's there. And now we have our switch. So let me name it, right? So let me say network switch. We know it's a network switch, but I just like to name things, right? Good. When you click on this again, you can also name it however you want. So let me just say Scalance switch. I have a spelling error right here. Yes. Enter. So we're renaming things now. See? Yeah, Scalance switch. And it's telling us the type. So here it's telling us that this guy is not assigned to anything. Nothing is managing it, whatever name of the component. So here I want to assign it to a controller. Of course, I want it to be controlled with from this PLC. So I'll just assign it to this. And when I click on that, it generally automatically enables a connection between both. Now, if you look at the PLC and the switch, there is no physical connection yet, right? But in the software, it already tells the switch that the switch will be managed from this PLC. So that's fine. We're still on the network view, and now we want to add all of this, guys. So I'll just put this somewhere where we can do copy paste so that we don't take a lot of our time. Okay, let me put it on this, on another screen. Yes. Okay, so our interface module is this. I'll copy and paste it here. search for it. We want it on the network. Good, we have it. So we add it to the network. Good. And then we have it here. So when we go inside of this device now, because we want to walk inside this rack, we're going into device view now because we now click on this guy, on this module itself. That's what we've just clicked on. What I have in front of me is actually not 2pn. On this software, I see 2pn, but what I have in front of me is not 2pn. So let me search for what I have. SysES7193, 7193, 6AG20, 0AA0. Okay, let's look for this. It's here. So let's see if I remove this, delete. Yes, actually, this is what we need. Oh, hold on. No, I should be able to. Yes, this is what we want to change. This one, not the module. See, it doesn't work with the module. We only want to change this. So when I drag this here, it's showing, do you want to swap? I just drop it in and it comes with this interface. Is this what you want to change it to? I said yes. So what I'll do now is click on this. Let me copy this number and put it on our document. So that's, yes. Okay. Now we want to add the first module here is the analog interface, which is what we have here. Control C, Control V. Okay. Six HD01. Yes. So it tells you you can put it anywhere between 1 and 6. If you also expand this, yeah, you see, you can put it anywhere here. But we'll just put it on the first because that's what we physically have. It shows us a white base. If you look at the image here, it's a white base. We go to the next one, the analog output. This, we'll put it on the second position. It shows us a dark base. If you check here, it's a dark base. We go to the next one, digital input. Yeah, do you want to continue the search from the start? Yes. So it has to go back up and look for it. It finds it. It shows us a dark base. However, what we have here is a white base. You can see. So because actually what you're configuring is this upper part. These are the modules that you're configuring and the base is automatic. But you can decide what base you want to use based on how you want the power distribution to be. So we have configured this. However, on site, what we have is a dark base, right? So I'll go into this module and click on potential grouping and say, I want to enable a new potential group, which is a light base unit, not a dark base unit. So I'll click on this. It also tells the device that it should expect its own 24-volt power supply connected to it, which we already have here. The next one is our digital output module, which goes on 4. Now we need to close the system. We need to close the line using our server module, which is this last small device that sits here. Server module, then we'll put it there. Perfect. So we have the rack complete. Now we want to name things like I usually do. So we can just say remote IO for this. Profinet interface. So we say um, remote IO PN X1. Okay, we have, we need to, we don't need a new subnet for this because in our drawing, everything is connected to the PLC using via the switch, right? So if we had a different PN, a different networking location port, then we could as well create a different subnet for it. But because it will be on the same subnet, this remote station has the same subnet 192.168.1.2 with the PLC 1.1. So we can directly just go now, click on this and go to the CPU subnet. Now it gives it 1.3, but we want it to be 1.2, which we can change. So it says the address is not unique. The next free address is 1.3. Now I'll go to the network view to check. You can click on this icon to show you the IP addresses. So the switch takes 1.2 because we configured the switch before the scaling, the remote IO. So we can leave it at that, or we can also change it. So I want to change it so that it can follow our hardware configuration. What do? I'll go into this guy and the Scalance interface as well. I need to name it switch PN. And I can go into this address. I'll change this first to 4 so that I can change this one to 2. So now this takes 2. And then I can go back to the switch and change it to 3 now, which then matches what we want to do. So we have 1, 2, 3. Do you understand? Anyone can work as long as they're not the same and they're on the same subnet. Fine. So they are all on the CPU subnet. Now I'll go back into my remote IO and do all the namings that I want to do. So first I'm on this guy. I've changed the IP addresses. What else? Nothing majorly for now. Module parameters, diagnostics on the voltage, all of this. No, I don't want that. IO tag, system constant. Currently, no. So I just want to rename these ones as well. My analog input, so I'll just name it to AI. Analog input. Potential group is already set. AI configuration. You can also set a lot of things here now. Diagnostics. You want to set how the channels are. For example, the first channel here is current. I want to set it to voltage, and I want the voltage connected there to be 0 to 10 volts. Channel 1, I also want voltage, and I want it to be 0 to 10 volts. So channel 2, I can leave it as current, channel 3 as current. You see we have 4 to 20 milliamps. I'll give you that as a take-home assignment. Also, our analog output, I'll just name it to AO for easy reading. Potential group is already set. Module parameters, you can also set the outputs. So what do you want the outputs to be? The first one is current. You can also set it to voltage, voltage 0 to 10. Second one, voltage. Because these modules allow it. There are some modules that do not allow you setting between voltage and currents. This one allow it. So some channels can be set to voltage, some can be set to current. It's also asking you for each channel. What happens in case the PLC stops? You have 3 options. Should it shut down? Should it keep the last value? Should it output substitute value? Depending on whatever you want. When you start programming, you will understand what you do to all of this. But for now, we'll just keep it at shutdown. Do you want diagnostics? If there are no supply voltage, if there is short circuit, overflow on the floor, wire break, all of these are very important. For now, we'll leave it the way it is. So this is an overview of this card. The first two channels are voltage, the last two channels 2 and 3 are current, 0 to 10 volts, 4 to 20 milliamps, and we've said all of them should shut down. We'll go to the third card, which is a digital input. General, we also change the name. It's a digital input card. We have our input modules. You also have your inputs here, diagnostics, channel 0, basically whatever you want to set. From template, from manual, just leave this ones as it is. I'm not enabling any diagnostics for now because I don't want anything out of the ordinary. Digital output, we've already set the potential group. Then we'll go to the server module and just rename it as well. And everything looks clean now. So on the overview, when you look at the rack, you can directly see AI, AO, DIDO, SM. You already see that directly. When we go back to the networking view, this is also not assigned. Now we will assign it to the PLC so that the controlling comes from the PLC. For now, it looks like we have everything we need for our configuration. You can see on the field, you see some green lights blinking here, right? So a lot of green lights blinking here. There is no power on this currently. I don't know why this is not working. I'll check it now. There's green light blinking on this, telling you that maybe it's expecting some configuration, or maybe a network cable is pulled out because maybe it's been configured before. This is green, so I would assume there are some connections currently, some configuration currently running on the PLC. So let me quickly fix this guy and see why it's not powering up. Hi, so I already fixed this and I basically had a wrong connection. I basically had wrong power connection. So that was the main issue. Now we'll go ahead to connect all our devices together using the diagram which we have here. So what we have here is we have our CPU. I'll remove this cover so you can see directly. We have our CPU connected to the switch. I'll connect to port 1. Now the PN lights up. We start seeing some blinking there, which shows that there is a physical connection. It doesn't mean there's any configuration happening there or whatever. It just shows there's a physical connection. And also we'll connect our remote I/O, which is usually sitting somewhere far away from the PLC or the switch itself. And then we'll connect this to port 0. So if you look at this, keep your eye on this. There is no lights blinking here currently, and when I connect this, we also start seeing some indication that there is connection. So what do we have to do next is to connect our PC to this setup. So our PC goes in here, then I'll connect this on my PC. Right? So I'll connect this on my PC. So from the configuration we have here, because everything here is on the subnet of 1, the subnet is the third part of your IP, which is the first part is the 192.168, and then the third part is this, in this case, 1, 1, 1, 1. So I'll set my PC to that same subnet. How do you do that? Let's go here. You click on this and just type Ethernet. So I'll type Ethernet settings and check what are the settings on my PC right now. So my PC is currently on subnet of 3. I'll change that. I want it to be 1, 1. And we said it should be 1.100, so that's fine. Save. So I'm setting my PC to 1. Now, one thing I need to do now, I haven't saved this. Let me save this and compile. I do a right click, compile, hardware rebuild all. So it rebuilds all the hardware configuration that we've done, checks if everything we did was fine. It says everything is fine, 0 errors, 2 warnings. That's fine. Before we download this, I just usually do a check first. And one of the checks is to see what's on the network. What are the IP addresses of this guy? Maybe currently they have IP address. What is it? There is a program called PRONETA. It's also from Siemens. It's made by Siemens. So you can also download that and you can use it. It's free. With PRONETA, you can scan the network which you're connected to, and it will show you all Profinet devices on the network. This helps me to know if these guys currently have some IP addresses that might be different from what we have configured on the project, which would help us to reconfigure the IP addresses so that we can download this configuration to these devices. Because if they have a different IP address, we might find it hard. We might. Another thing that you can do from within the software is you can also go here and say you want to check online devices. Here. So if you say you want to check online devices, I know I am connected on this connection, and then you say update accessible devices. So within the software, it can also do a search to check, okay, you're connected here and there are some devices connected. What are those devices? So you can see it shows you, okay, now I see clearly that this PLC is not on subnet of 1. It's on the subnet of 0. Of course, from within the software, I can also do online and diagnostics, which would help me to do two things. I can change the IP address from there. I can also change the Profinet name from there. But I want to show you one of the tools which we use on site. It's called PRONETA. So PRONETA is a network analysis tool which actually helps you to do quite a lot of things. In this case, you can see what it's showing me. So this is what it sees on the network right now. It sees a PLC which I have named OMA 7200. It sees something called remote IO. It sees the switch. The remote IO do not have IP addresses. The S7 has IP address. So I can change this IP address and say I want it to be 192.168.1.1. If I click on enter, it says, do you really want to set the IP address? Yes, I want this PLC to have that IP address. So let's see if it sets it. I don't think it did. I'll try again. 192. Why is it? Okay, yes. 192.168.1.1. Enter. Yes. Okay, so it looks like that didn't work. I'll refresh this to see. So basically it looked like it didn't work. It's still 0.3. Scalance switch is this. Looks like this is what it says. So we can go back into the PLC. I'll go online diagnostics with this PLC. Hopefully I can get a connection to the PLC. Yes. First, let me see if I can set time to be sure that I'm connected to it. So I'll say apply. Yes, so now it takes the timing from my PC. So now I can go into IP address and see if I can set IP address 1.1. Assign. The set command could not be executed. Okay, looks like that didn't work. Okay, now we've started doing troubleshooting, right? We started doing troubleshooting. Okay, so this is factory reset. I don't want to go into that yet. So let's go into PRONETA name. Let me set PRONETA name. Probably I can use that. So, LED flashing. Is it flashing? Yes, it's flashing. PRONETA name converted to this. Yeah, this is what I want. Okay, it's currently running. Let me stop it. Let me stop the CPU. Remove the LED flashes. Yeah, the CPU is now in stop, right? Now let me see if I can set the IP address again. 1.1 assign IP address. So this is one of the challenges you would encounter as a programmer, as a control engineer, when you start going into that IT space. You would have, yes. So in this case, it looks like we were able to transmit the parameters. Parameters were transmitted successfully. Let's check on PRONETA now. Good. So it's changed. We've been able to change the IP address. Good. Now let's go to PRONETA device if we can do that. It's not giving me the option to do that. Okay. It's not giving me the option to do that, but fine. Now that we're sure that the IP address is fine, let's ping the PLC to see if my laptop can communicate with the PLC. I know the PLC is now 192, so I say ping. I open CMD command prompt ping 192.168.1.1. Enter. Fine. So we're pinging and we get replies. We get replies from the PLC, which is fine. Now let's go to the remote IO. Are we able to also change this IP address? Let's try 192.168.1.2. The remote IO is 2. Enter. Now this is green. The PLC is green. These ones are still blue. That didn't work. I think so. That didn't work. Okay, it worked. We're good. I can also ping to be sure. That was 2. Good. So we can now communicate with this remote IO station. Very good. Now let's go ahead to change the Scalance switch. 192.168.1 and 3. And then this is, yes. Good. So we have the Scalance switch as well. So let's ping the Scalance switch. 3. Good. So we are able, our laptop is able to communicate with all 3 devices because we've set the IP address. And now PRONETA sees the correct configuration, how we are connected. My PC is connected to the Scalance switch on port 4. That's what it sees. The remote IO station is connected. The PLC is connected. So everything looks good. The only thing now is the names, the configuration, everything, which looks fine. So PRONETA has really helped us in this case. So what can we do now? Again, let me go if I'm able to set. Okay, no, fine. So let's go back away from online and diagnostics and let us see if we're able to download this configuration, compile, download to device, hardware and software. Okay, so it's asking where are you connected. So I wanted to show all accessible devices. I wanted to also check. Okay, we're on the CPU subnet, right? Because we're connected. Okay, this cannot be modified. Fine, whatever, as long as it can see it. So I'll just say direct at slot 1. Let's search. Okay, it's attempting to. Okay, refresh. Incompatible firmware. Fine. So we have an incompatible firmware version. Great. So let's go. How do you fix this? I like when these issues come up during trainings. So it tells us directly that SF1200 has incompatible software. And let's check that. We go back to accessible devices, update accessible devices. We can see all our IP addresses have changed. We go into the PLC directly. Then we go into online and diagnostics. This is a very good part, and I wanted to show you this as well. I thought we could do this on another training. So we go to functions, and then we go to firmware update. Here, it shows that the online firmware is 4.4.0. This is the firmware we have currently on the PLC, on top of it. However, in our configuration, let me see what we have. So I can split the screen. Okay, again, I'll go to device configuration. Yes, so I click on this, properties, and on the general, we can check. So our firmware, which we have configured, is version 4.7. However, what we have online is 4.4, which means, of course, we need to update the firmware of this PLC, or we downgrade the firmware of our configuration. Do you understand? So we can directly go to change firmware version of our configuration and look for version 4.4. This is current our current device which we've configured. We can directly go back to 4.4, which makes everything fine. Or yeah, so these are the functions that come with the 4.7. It's telling us here if we change this. So if I go to 4.4, for example, it will tell you all the things that will change. See, there are quite a lot. So it means version 4.7 has all of these features. And if we downgrade to version 4.4, we would lose all of these features. So I'll say no. We want to keep version 4.7. So if we want to keep version 4.7, then we need to update this PLC with version 4.7. So how do you do that? Very good. This is one of the reasons why I told you to register on the Siemens platform. So I'll copy this article number. I've copied it. I'll go on the Siemens platform, and then I can just type the article number and say firmware update. It directly takes me to the Siemens portal where I can get the update. But before you can get the update, it's showing me in German, of course. Let me register, let me log in. So right here, I'm logged in. And then we see all the firmware versions which we can download for this PLC. I'll go back again to confirm what we have on this guy. We have version 4.7, just 4.7. And on the web, we see different versions. There's 4.73, there's 4.70. So let me download 4.73, which is the latest. So I'll download that.
So we have the file downloaded. I'll unzip the file. Okay, so we have the file downloaded now, and I can go ahead to pick the file. So let's go firmware file, downloads. So it checked. Okay, does this look good? Now we want to run update. The firmware has been loaded on the PLC, and now it's being activated. So we'll wait some few minutes as well for this to complete. Okay, we're back. The PLC's firmware has been updated. As we can see now, it's 4.7.3. However, the IP address has changed back. So let's see if we can change that again. And we can confirm using PRONETA to see. Yes, so it's 1.2, shows 1.2. We can also ping it. Yeah, we can get data. So fine, everything looks good again. Fine. So now let us see if we are able to do compile and download. So hardware and software only changes. And then save this. We don't have any errors, I presume. No, we don't. So let's see, download to device. Hardware configuration to device. Let's see how that goes. Okay, reset module. Delete all. Walk and load memory will be deleted. Yeah, delete all. Yes, I think that's all. Yeah, load. So let's load our configuration on the device. If this were a PLC that had its own HMI in front of it, like the S7 1500, you could see the current status, which would write downloading to device. And then you can also monitor from its local HMI. In this case, the S7 1200 does not have its own HMI, so we can only see everything through the software. So if you were standing in front of this PLC right now, you wouldn't know what was ongoing. Okay, so I needed to show you this because it says it's not able to download to the device because it's unable to reset the module, right? So what I'll try to do now is to see if I can do the reset myself. I'll go to online and diagnostics. So the reset it's talking about is the user program and everything that is currently sitting on this memory card that is on this PLC. So I hope you can see this. So it's talking about the user program on this memory card. So let's see if I'm able to reset that, and then usually that's what blocks the download most times. So here I have navigated to the S7 1200 PLC, and here on the format memory card, I want to format the memory card so that all the settings on the device can be cleared, which would then allow me to load my configuration. Usually you're not usually expected to do this. You don't really need to do this often. I think I'm doing this basically because I've been using TI version 16 before now, and this is the first time I'm loading TI version 20. So a lot of changes have happened between the softwares, and the PLC is currently confused. Let me see if I can connect to the device again. Update home S7. I'm kind of baffled that it's still showing the old IP address, even though PRONETA was showing that we already have the new IP address on it. So I'll just check again. Functions, IP addresses, 1.1. Yes. Mm, yeah, 1. Don't use router. No router. Yeah, the PLC is 1.1. Yeah, transferred successfully. So update accessible devices. Let's see if it's changed. Yes, now it's changed. 1.1, correct. Now, let's see if we're able to load configuration on this device. Let's see if that works. Download the device, hardware configuration. The IP address of the device does not match the IP of the device. Yeah, so I still want to connect. So connect. Download the device. Yes. Still not able to download to the device. Error downloading to the module CPU common. Okay. I don't see any CPU common here. So I'll do some troubleshooting and share what I find with you. So it looks like I've been able to finally download to the device, and I can directly tell you what happened. The Profinet name was what was limiting it. So I checked on PRONETA, and here it kept showing S7 ohm, which was the old naming on the device. I could see that the firmware version is correct, 4.7.3. The IP address was correct, but the name was wrong. So I connected my laptop directly on the CPU. I removed it from the switch, connected directly on the CPU, and then I loaded the hardware configuration to it. Now I can say start module and see if it will start. So it's currently trying to start. It's loaded the hardware configuration. It's trying to start. So it's running, but you can see some error here. And it's showing those errors because, of course, in the hardware configuration, we have some network on the line. So it currently cannot see this guy, it cannot see this guy, because in the hardware configuration, it's there. You understand? So it will show you which one is green. The PLC is green, but it's showing us that we still have some errors here. You see, if we go to the network view, it will show you the devices that are okay. It cannot see this guy. It cannot see this guy. It shows that this guy is running, but it's running on some kind of mode. So I'll go offline, return my connection to the switch now. So all the connections are the way they are supposed to be now. However, I still need to transmit the hardware configuration for these other guys, which have not been done. But before doing that, let me quickly show you um, how I did the naming, the Profinet naming. So if you go into your configuration, let me go to the network switch itself, and I'll go into the properties. Yes, okay, properties. If I go to the Profinet interface, that's where you'll find the Profinet name, which the software generated. So this is the Profinet device name. I'll copy this. I'll go to my PRONETA. Under the switch, I'll just put it here and press enter. Do you want to assign the name? Yes, I want to assign the name, network switch. I'll also go into my software and go to the remote IO, copy the Profinet name and use that as well. Yes. Profinet name is very, very important when it comes to communication, Profinet communication. So now we've set all of this. Profinet IO names, we've set the name, we've set the IP. Everything looks correct on this part. You can directly see that this guy has stopped blinking. So it tells you that, okay, fine, it can communicate with the PLC now directly. It tells you that directly. I can communicate now. All the blinking lights have stopped. Now let's go into our TIA portal, network view. Let me download, save, and let me re-download hardware and software. Let's see. See that the PRONETA software really helps a lot. I will also, in our GitHub page, if you go to the PLC training page and you go to the introduction, yes, I think you should find the link. It's not on the introduction. Let me go to resources and we have a note somewhere. Yes, instructions basically. You'll find the link to download all of these devices. I need to add PRONETA in here somewhere. So I'll add PRONETA so that on this link you can also find the link to download PRONETA there. So everything is up to date. Download our user. Yes, load. Let's see if anything changes. So it's loading configuration. I hope this doesn't take a lot of time. Okay, the software has not been loaded because everything is up to date. Okay, it says everything is fine. Now let's go online. Okay, so our remote IO is green. Our network switch is still red. The PLC is green and red, which shows that there are some issues on the PLC. We can directly go on the PLC and do online and diagnostics to see what the issues are. But basically, we have our configuration on the PLC. Um, we can see our remote IO station. So let's go to our diagnostics to see session authentication. Basically, it's just session authentication successful, IO device failure. I don't see any major error in lower level component fault LED. Module exists, but it's faulty. Okay, so it's saying the Scalance switch exists, but it's faulty. Yeah, so we need to find a way to fix this, but that's not a major issue for us now. So I'll also try and go through this, see how I can fix this and let you know what I find. But basically, our hardware configuration is fine. We can directly go into our programs now to start writing our programs. As we can see, everything is green except the switch itself. I'll try and get it green. So inside the program, there's nothing written here basically, but we can go online just to see. Yeah, so we're currently online. inside this block right now. Thank you very much. Okay, so another issue we have with the switch also has to do with the firmware version. So it says the installed online firmware, which is version 4.2, is different from what we configured, which is 4.4. So what's running on this switch is 4.2. However, in our hardware configuration, we have 4.4. So I'll go ahead, download version 4.4 and load it on this device. So currently I'm loading the new firmware version 4.04, which I downloaded from the Siemens portal, version 4.4. And you can only upload the Scalance firmware version, not the way we did it from TIA. You have to go into it using the IP address. I know the IP address, which is 1.3. You log in with the standard password, admin username, admin password. And then on the information, you can see the current firmware version. Then you come to load and save. Here I clicked on load. I accessed the device, the file which we downloaded, and now I'm uploading that. So let's see how this goes. So right here it says the file was successfully loaded. We need to restart the device. I said yes, okay. So we're restarting the Scalance switch now. The device is restarting. You can see all the lights are blinking, and basically it should restart with its new firmware. Right now, the remote IO is blinking because it's not seeing any connection because this guy is basically off at the moment. You know, it's restarting. So this is also showing errors and all of that. All connections are currently off. We can see it's basically loading all the files that we've loaded on it. So we'll wait till everything is done and hopefully we see some greens everywhere. So some good news. Everything looks green. Everything is green. The remote IO is green. The Scalance switch is green. The PLC is green. PLC is currently not running. So let's go back online to see. Let's go back online to put it to run mode. Is it not running? Oh, it's currently running actually. It's running. That was the connection link. So it's currently running. Everything we see here now shows green, although we still have some information to see. The firmware is now 4.4, so we look good with the firmware. Do we have any issues? No issues. PRONETA interface, everything looks good now. So basically everything looks good. We have green, and although we have one red here, let me see online and diagnostics if there's any important thing to fix, which I doubt. Module exists, okay. Diagnostics buffer, yeah. Session authentication successful. Yeah, for now everything looks very good to me. Yeah. Okay, so connection to switch aborted. Yeah, we only have one small indicator here, which I currently don't know what this is, but this doesn't affect conflicting diagnostics data. Okay, so basically it's just conflicting diagnostics data. So I would assume that if I reset all of this, if I set power on and off on all of this, all these issues should go away. So let me go online with the switch to see if there's anything I need to know. If there's anything I need to know, fine. If there's nothing we need to know, then we're good to go. Yeah, online and diagnostics. On our PRONETA, does everything look good? Looks like it. So diagnostics, yeah, module exists and it's okay. We don't have any issues on the device. Yeah, so like I mentioned, you can see now everything is green. We have green everywhere. The switch itself is green, the PLC is green, everything looks green. If we go to our network view, everything is green. So thank you very much. This has been a very long one, but it's good that you've seen everything that it takes to have a PLC configuration, downloads, firmware updates, everything all encompassing. Thank you very much. I would expect your questions or comments, and then I'll upload all the resources that you need as well. Thank you very much, and see you next time.